In the previous tutorials, we saw the type of data that are for now included into the BraDiPho framework and how we can actually browse them. We also saw how you can produce your own annotations, but an important point that we haven't tackled yet is the actual applicability of this framework in order to cross-match dissection and in-vivo tractography. So today I'm going to show you a couple of examples that concern how we applied BraDiPho to the evaluation of the tractographic reconstruction of the associational connectivity of the angular gyrus in vivo with the dissection data. As you can see from the DB3, I have uploaded in Cloud Compare the bin file containing all the dissection epochs of subject 2, one tractographic reconstruction of a bundle that is registered to the specimen space, and the bin file containing the cortical and subcortical annotations for this subject. While this bundle is of interest for us, I expect that you might want to have your own tractographic bundles reconstruction within this framework. We are actually providing a service for the online registration of your own bundles reconstruction to the specimens spaces. To do so, you just need to go to the BraDiPho website under the Tools section, upload the bundles TRK and its reference image, which preferably should be MNI. In a few minutes, the bundle registered into the specimen space will be ready for download, and you will be able to download it following 3 different formats. If you want to open it in Cloud Compare, I suggest you download the PLY file. Once you have your data all in Cloud Compare, you can start studying the anatomy. The bundle that I'm visualizing now connects the angular gyrus with the middle frontal gyrus. By visualizing the cortical annotations of interest on epoch 1 together with the bundle's reconstruction, I can make a quick visual sanity check of my registration. It is evident though that I cannot study connectional neuroanatomy by stopping at the cortex. So the first thing to do is to go and look for my connection in the dissection data. I can do it by scrolling through the different epochs of dissection up to the point where I find the epoch of dissection that is suitable for my data. We can see that epoch 2 is just the decortication of the sulci. Epoch 3 is the exposure of the superficial layer of the posterior transverse system. Epoch 4 still focuses on this system with the isolation of deeper fibers. And finally, epoch 5 starts exposing frontoparietal connections. I'm gonna identify the cortical landmarks of interest. So I'm opening the cortical annotation for the middle frontal and the angular gyri on this specific epoch. And this is gonna help me out in identifying the fibers that connect one cortex to the other. By visualizing the tractography, I can see that there is into my tractographic reconstruction a short connection at this level that goes from the middle frontal to the angular gyrus. The bundles annotation that you can produce following the same process that was outlined in tutorial 2 for cortical annotations allow you to highlight the patterns of connectivity whose existence you want to test. But if I consider again the initial bundles reconstruction that I started from, what I'm seeing here is only part of it. Indeed, we saw that at this level of dissection we can extract the shortest, most ventral and lateral part connecting the posterior segment of the middle frontal gyrus to the angular gyrus. The question now is, are these longer fibers that I see in my tractographic reconstruction traceable in the real anatomy? Tractography gives me a precious information that actually should be considered while doing the dissection. Indeed, these longer fibers are also deeper, more medial. So if I want to test the existence of this type of fibers, I need to go deeper also in the dissection. I'm therefore moving to epoch 6, where the most posterior part of the middle frontal cortex has been removed, allowing for the exposition of deeper fibers connecting to a more anterior segment of the middle frontal gyrus. I can see that there is actually connectivity between this cortex and the angular gyrus. By visualizing the bundle stratigraphic reconstruction, I can actually verify that we have a match. Overall, by having both in vivo tractography and ex vivo dissection within the same space and in a 3D rendering, I was able to verify, first of all, the existence of my connection. Then, to test the anatomical reliability of my tractographic reconstruction, and on top of this, I was able to gather information about the anatomical features that constrain the mediolateral organization of these fibers. But now I'm gonna provide you a second example that gives a slightly different perspective on how we can use this framework. So on the same epoch of dissection, I can spot a second connection that is of interest for me because it concerns the connectivity of the angular gyrus again. This connection goes from the angular gyrus to the superior frontal gyrus, and this is its representation in the real anatomy. I'm gonna now reset the view and upload the tractographic reconstruction of this connection. As you can see, there is a mismatch between my tractographic reconstruction and what I get in this dissected specimen. So my tractographic reconstruction seems to be more dorsal and slightly more medial, because you see that it's passing below what remains of the dorsal part of the precentral gyrus. This is not a bad sign though, because it just means that what I got in tractography, it's not what I can get from this type of dissection approach. So if we probably would have gone more medial, we could have get this type of connectivity. So on one hand, this does not tell me that my tractographic reconstruction is anatomically unreliable. Still, there are two things that really strike me. So first of all, if I would have done a canonical comparison between my tractography and a dissection picture in two separate spaces, I could have stressed that this connection exists, and then it would be chapter closed. Second, there is an important detail that I haven't revealed you yet about this tractographic reconstruction of this connection. That is the fact that this representation comes from the concatenation of 39 subjects, and therefore I would expect my tractography to be more comprehensive of interindividual variability. So at this point, the question that arises is, why am I not getting these longest, more ventral connections between the angular gyrus and the superior frontal gyrus? Is there any kind of information from the diffusion data that is not allowing me to get this type of connectivity? Is my tractography algorithm behaving correctly? How can I enhance the information that I need to have a better and more anatomically reliable representation of this connection? I'm leaving these questions open, but this was just to stress the fact that in some cases, BraDiPho might lead to a complete match between our tractography and the dissection data, but in other cases, we can also use the information that comes from ex vivo dissection to have a hint on what can be done better on the in vivo side. As usual, if you have any questions, curiosity, or maybe some suggestions for new tutorials, just reach out to us.